Hello and welcome back. We have understood the unsupervised learning algorithm PCA, principal component analysis, theoretically. When I say unsupervised learning algorithm, it will not consider the y value, it will take only the input values x1 till xn and tries to reduce the dimensionality. While reducing the dimensionality, it doesn't know whether the reduced data set is useful to make proper predictions on y or not. That's where we call it as unsupervised learning algorithm. It will not consider y value. We understood theoretically. Let us try to understand graphically a little bit so that you will get better understanding. Suppose that these magenta dots are your data. I am saying dots and data, right? It's a scattered plot. This is x1 and this is x2, two input variables. And this dot is x1 comma x2, x1 comma x2, like that. The PCA takes this data and does a mean centralization of data. What is mean centralization? Calculates the x1 bar for the first column, first feature. It calculates the mean, and for the second column it calculates the mean, subtracts the first column's mean from the first column data points, and second column's mean from the second column data points. So that is called as mean centering. It takes this data and does mean centering. When it does mean centering, right, the data points moved a little downward. I think you can see that here, right? And then it calculates the first principal component. Before it is calculating the first principal component, it takes the mean centered data and does x transpose x. When you say x transpose x, inner product, you will get the covariance matrix. We did mean centralization and then doing x transpose x, that will give you a covariance matrix. On covariance matrix, if you apply eigenvalue decomposition, you will get principal components. So we'll see that math in a moment, but let us try to understand graphically at a high level. We took the data, we did mean centralization, and then found the first principal component, which is going through the data. It's a linear combination of your input variables x1 and x2, and then we'll project the perpendicular projection of the data points onto the principal component. In linear regression, it is not perpendicular projection. In linear regression, if your x is 3, you are going to if x is 3.5, you are going to predict a value here on this line. It is not perpendicular projection. In PCA, it's a perpendicular projection. You project your data and find the dots where exactly it is being projected on the first principal component. The first principal component is the one which is capturing the most variance in your data. Second principal component is going to capture a little less variance. Third one even less. Fourth one even lesser. So the nth principal component will extract very least amount of variance from the data. Because if you look at this data, if you look at this line, the principal component, it is actually going in the direction in which the data is most correlated, right? The data points are very close. When you are doing projection, right, the loss is going to be less. Okay, we did on the first principal component. Once after doing the projection on the first principal component, we actually reduced the color a little bit, because to symbolically show that some essence is been extracted by the first principal component. And now it takes the second principal component, which is perpendicular to the green line, so right, the orange line, and then projects the same data points onto the second principal component. Now it rotates these two principal components so that the first principal component becomes x and second principal component becomes y. If you have more, right, third one becomes z, fourth one becomes whatever the axis is letter is, that it becomes, right? Once after projecting the data points onto first principal component, second principal component, it rotates the principal components and makes them as x and y. Now your x1 y1 will become z1 and z2. The data points here x1 and x2 originally, after extracting the essence onto after projecting the data points onto principal components and then rotating, your data points actually changed. Your x1 x2 values, they may be 3.5 4.5, they may become 2.5 and maybe something else. So now the transformed data is going to be the z1 and z2, the two columns. Now z1 z2 here, z1 z2 here, z1 z2, z1 z2, like that, it's going to take that. So that is how PCA works on data. Okay, visually we understood how it is exactly working. In the next session, right, we will understand how mathematically it is calculating it. Which technique I am saying, eigenvectors, eigenvalues, and covariance matrix, how that is. We will see this in next session. Thank you.